This is Earth, and this is Kepler 442b, an exoplanet that's better than our home. But what if I told you that there are hundreds of thousands of such planets throughout the universe? Where are they? How long is it to reach them? And most importantly, is there life on them? In this video, you'll find out the answers to these questions, as well as what planet in the solar system can develop life, what exoplanet is the closest to us, and what a star system with 3 Earth-like worlds looks like. Let's start our journey through the most habitable planets with the closest celestial bodies to us. One of them is Mars. The red planet has always been the subject of detailed study, dreams of colonization, and the search for life, which is why it's the most explored planet in the solar system, after Earth of course, and its exploration continues apace thanks to missions like NASA's Perseverance and Curiosity. Thanks to them, we have learned that during the Hesperian period, some 2.51 billion years ago, Mars was similar to Earth and was covered by one giant ocean in the northern part, seas and rivers, and superb temperature of 100 degrees Fahrenheit. But how might Mars be interesting for us to look for life? Despite its dry and desolate nature, Mars has many factors that make it attractive for exploration and potential colonization. For example, Mars has seasonal climate changes similar to Earth's, polar caps containing frozen water, and historical evidence of rivers and lakes in the past, as well as recent discoveries suggest liquid water beneath its surface. Scientists from NASA and ECA say in all seriousness that under the surface of the red planet, at a depth of 30 to 300 feet, there are hidden caves filled with liquid water, and at a depth of 3-6 miles, there are entire oceans of salty seawater. And while modern rovers can't drill that much at the Earth, space companies are already preparing the Icebreaker Life mission. It's expected to be able to descend 1,500 feet deep into Mars, which will be enough to study at least the water caves, their water composition, and temperature. If conditions on the surface are harsh enough, with low atmospheric pressure and high radiation, the underground regions of Mars may provide more suitable conditions for microbial and perhaps more advanced life. Mars is therefore a prime target for the search for life and colonization. Moving on, unfortunately, there are no other potentially habitable planets left in the solar system. Venus and Mercury are too hot and close to the Sun, and after Mars, they're only gas giants, with a small dwarf Pluto on the outskirts of the system. But of course, space doesn't end there, and we're off to the closest star system to us, Proxima Centauri, which consists of 3 stars, is only 4.24 light-years away, and most importantly, has an exoplanet with 87% similarity to Earth. It's Proxima b. This high ESI percentage is due to several factors. The first is the planet's location in the habitable zone of its star, which means that conditions on its surface may allow for the existence of liquid water, a key factor for life. In addition, scientists are attracted by its diameter and mass, which are not very different from Earth's, as well as the fact that in some areas the temperature can be close to those values found in the tropics. But it's worth noting that Proxima Centauri b revolves around a red dwarf. So when we fly there, we may find that as a rule, stars of this type can be unstable and throw out powerful starbursts, creating radiation. However, if Proxima Centauri b has a magnetic field similar to Earth's, or a dense enough atmosphere, this could protect it from such emissions. And even despite the potential threats from the star, scientists continue to actively study this planet, as its proximity to Earth and presence in a habitable zone make it one of the best candidates for the search for life and human exploration. Despite its many advantages, Proxima b has serious disadvantages that prevent this planet from being our refuge. So we fly further into the depths of space to one of the most promising planets, which is about 40 light-years away and orbits a red dwarf star. LHS 1140b is a super-living planet with a hard rocky surface, whole reservoirs of liquid water in the lighted areas, and glaciers in the darker ones, and quite a moderate temperature. But it's not just this that attracts astronomers. It's its dense atmosphere, which has been preserved by the low activity of its parent star. This reduces the likelihood of destructive starbursts that could wipe out the atmosphere. We can confidently state that having a magnetic field, which by the way is not present neither in Mars nor in Proxima b, stable climatic conditions as well as similar sizes, LHS 1140b has all chances not only for the emergence of life but also for its evolution. Perhaps when we reach the planet's surface, humans will encounter underwater creatures like those that live in our oceans. Now, after getting acquainted with LHS 1140b, we move on to a much more interesting world. Next up is a celestial body that may surprise, even experienced space explorers with its age and ability to support life. Welcome to Captain B, a planet that predates the formation of Earth, Mars, and Venus, the gas giants, and even the solar system as a whole. One of the oldest known exoplanets, it orbits an old red dwarf at a distance of about 13 light-years from Earth, making it certainly one of the closest exoplanets to us in the habitable zone of its star. But why are we emphasizing its longevity so much? Is it so important? Yes, because such a super-aged planet is thought to have a solid surface, and its conditions may be stable due to long evolution. Given the age of the planet and the presence of conditions potentially suitable for liquid water, Captain B is seen as a candidate for studying ancient life forms that could have originated on its surface and evolved into more complex species. Just imagine if life ever existed on this planet. It could have evolved over billions of years. Studying this ancient planet is also important for understanding how planetary systems can evolve and remain habitable over long time periods. You'll agree it's mind-boggling, but the truly mind-blowing planets are yet to come. But these are all icy worlds, more like the planet Man from Interstellar or Earth during the Ice Age. We need something with a warmer climate, don't we? We'd like to introduce you to one of the first discovered super-Earths, Gliese 581c. Planets in this class have masses that exceed that of Earth, but remain much smaller than gas giants like Jupiter and Saturn. They typically have masses between 1 and 10 Earth masses. In the case of this planet, the weight is about 5 Earth masses, making it a true giant. Gliese 581c orbits its star at a very close distance, about 0.073 astronomical units, thus receiving more heat than the Earth from the Sun and completing one full revolution in about 13 days. An intrinsic aspect is the possibility that a planet could be tidally locked to its star. This would mean permanent day on one side and eternal night on the other. But is that a bad thing? Yeah, it creates sharp temperature contrasts, but in the terminator zone, the area between the day and night sides, conditions may be suitable for sustaining life. And even if we don't find the conditions we expect when we arrive there, there's a planet waiting nearby called Gliese 581g, which promises to be even better than its neighbor in many cases. A greater distance from the Sun, temperatures of 50-70 degrees Fahrenheit, and lower gravity. Now what you've been waiting for, some of the best planets for life discovered by the crucial Kepler mission. What makes it so significant? And it's significant because the telescope with the same name was originally launched with only one mission, the search and exploration of exoplanets. And over the course of its work from 2009 to 2018, the mission has discovered more than 2,600 planets, changing our view of the universe by showing that Earth-like planets are extremely common, and many of them could potentially be habitable. But if we talked about every single one of them, the video would take many weeks to complete, so we've chosen 2 of the most promising of the exoplanets that you definitely need to know about. The first of which is Kepler 22b, which is 600 light-years away from Earth and orbits a star that is very similar to our Sun. This means a very stable starburst environment. The planet is also believed to have a very dense atmosphere, being located in an ideal zone where the surface temperature may allow for the existence of liquid water. However, one of the most interesting facts is its color, which is unlike other exoplanets. Kepler 22b has a bright green hue, which could indicate either a rocky surface of this color or, mind you, the presence of entire forests covering the planet. This could mean that right now, life could be growing and developing in this celestial body just as it is on our Earth. And the second planet, called Kepler 442b, is more than twice as far away from this green world at a distance of 1,200 light-years. As you can imagine, if this planet is mentioned in this video, then there must be something interesting, right? Yeah, of course, but what exactly it is will surprise you a lot. When scientists analyzed many planets on the parameter of potential habitability, they came to the conclusion that Kepler 442b is a more habitable place than Earth, with a score of 0.836, while our planet had a score of 0.829. Can you imagine? By comparison, relatively inhospitable planets like Venus and Mars had scores of 0.3 and 0.422 respectively. This similarity is due to the same rocky surface, abundant water, similar mass, and a temperature of 32 degrees Fahrenheit. There's also a dense atmosphere, which can protect the surface from cosmic radiation and maintain climatic conditions suitable for the development of biosphere. Unfortunately, it's too early to make any serious statements. At least we need to better understand and analyze the data of this planet, its atmosphere, its composition, and temperature. But it's already clear that Kepler 442b is a leader among planets similar to Earth. So we come to the climax of this video. Throughout our story, we have always mentioned planets singly, as it's very rare for habitable worlds to occur in large groups. Even in the solar system of the habitable planets, there's only Earth. But unexpectedly, in 2016, a system with 7 rocky exoplanets was discovered, which are very similar in their parameters to our planet. And in case the first 3 planets with code names B, C, D are too close to their star, which makes their climate similar to the conditions on Venus, the planet H and the opposite too far away, which tells us that there will be met with glaciers and snowy deserts. But celestial bodies E, F, and G are located in the habitable zone. Just imagine, 3 planets that can support life on themselves and are also in a neighborhood. As we begin our journey to these worlds, we'll first stop at Trappist 1e, the closest potentially habitable planet to a star. The exoplanet has a radius almost identical to Earth's, and its mass is about 10% less than Earth's, which eliminates the possibility of additional pressure on the human body by increased gravity. Also, if by studying it we find that the composition of the atmosphere is similar to Earth's, then we can be sure that it has greenhouse effect. That solves a lot of problems like temperature, liquid water, and radiation, all of which makes it the most Earth-like of all the planets in the Trappist-1 system. Next up, we have Trappist-1f. This planet is slightly larger than Earth, with a radius 4% larger than Earth's and a mass about 68% of Earth's. And it's located farther from the star than Trappist-1e, at a distance of about 0.037 astronomical units. This indicates that it will be slightly colder than its neighbor, but of course it's worth noting that if it has a dense atmosphere with greenhouse gases, the temperature could be high enough for life to develop on it. Now, traveling even farther out, we encounter the largest exoplanet in the system, planet G. Being in the periphery of the habitable zone, it greets us with a cool climate, which scientists estimate may be similar to that of the Scandinavians. But at the same time, due to its size, it may indicate that the planet has a denser atmosphere, which in tandem with the greenhouse effect, can equalize the temperature at the poles and increase it in general. On the plus side, this mass may also indicate that Trappist-1g has an active geology, which is important for creating and maintaining habitable conditions. However, due to its distance from the star, conditions on the surface may be harsher. And despite the large number of Earth-like worlds in our universe, even the nearest Proxima b would take us about 80,000 years to reach. That's an unacceptably long journey, isn't it? We need to either look for ways to accelerate so fast that any goals we reach will be reached in a matter of weeks, or look for alternatives for a new home somewhere nearby. But how can we do both within today's technology if even a flight to the outer solar system takes several years? What alternate planets are there if we've already realized that there is only Mars, and that with a number of serious drawbacks? Especially for you to get the answers to all these questions, we recommend watching our previous videos on how we can overcome speed barriers by traveling deep into the Milky Way, as well as how to turn even the most uninhabitable planets into Earth-like worlds through terraforming.